Okay, let me please remind everybody, you've been really good about it, but please don't talk so I can be sure I can post these, because some people aren't here, might have been counting on Zoom and we're dead in the water. They can't even access the internet through the wireless. And if I do, Zoom still isn't behaving. Multi-factor identification is screwed up. So, and this is the kind of thing we always expect in their finals. At critical times of the year, the first 2 weeks and the last couple of weeks of classes, when all the technological glitches seem to occur. Now, whether that's true or not, it might just be that they're particularly inconvenient those times, so that's what we remember. Okay? So there's a self-selection in that perception. Okay, well, I don't want to sound too cynical, but timing is particularly bad. Okay, so we want to factor. I'm going to run through these pretty quickly because the videos are all there. Okay. Well, there's a good reason to question that one, because I don't think that one factors. Okay? And we can tell that it doesn't factor. So this doesn't seem this will work. We could test. I'm writing out the quadratic formula, going to do some of the arithmetic. So this equals, well, we're going to have, the main thing we want to look at is this radical, and that's going to be 324 and 72, okay? Which is 396. If I do it right. And the square root of 396 isn't a whole number, okay? So this is not a perfect square. Because 400 is a perfect square. 20 squared is 400, right? And the next lower number is 19, whose square is 361, okay? So that's not 361, it's not 400, and there's no perfect square between 19 squared and 20 squared. So that doesn't work. So let's modify this a little bit. Try x squared minus 18x plus 11. Well, we could write this as x when I did that, that was incorrect. It should be x squared minus 11x plus 18. Okay, so this is going to be x and some number, x and some number. Now we don't know if it's going to be plus or minus here. We don't know if it's going to be plus or minus here. So we try all the different combinations. Now we've worked through that. We've done that. I'm just reminding you of that. Now say, well, we're going to settle on x minus 2 and x minus 9. Because if we multiply that out, we get a minus 2x and a minus 9x, which gives us the negative 11x. And of course, minus 2 times minus 9 is 18. So that's how you would factor it if I put a good number in there. There's apparently a glitch in the program, so I'm going to have to make myself a note to watch for that. Okay? And I'm just curious how bad the glitch is, so I want to look at version 2. It probably doesn't seem to be working right. That one doesn't look good either. There's another one that looks bad. Okay, so apparently that problem's generating wrong, so before I generate the test, I'll fix that, or I'll just edit that when I post the test, since we don't have that many people. I can probably get away with that. Okay, so anyhow, there it is. Okay, moving on, rational expression. So the problem is stated this way. Put this in the form P of x over Q of x, okay? All that means is find the common denominator and add them up. And that'll give you a numerator and a denominator, okay? So let's just do that, and then we can say what the P of x and Q of x thing is. So we're going to have, okay, well that's 1 over x minus 2 times x minus 5 over x minus 5 plus 1 over x minus 5 times x minus 2 over x minus 2. Now, is that familiar? We did that back in chapter 3, right? Okay, so you might want to review that. I'm pretty sure we've done that in class. Since I have 3 classes that all do this, I can't say I'm 100% sure, but I'm pretty sure. And if I do find that there's something on here that everybody misses, I'll definitely go back and check and make sure it's something we really did cover, both through the open math assignments and in class, okay? But anyhow, there it is. Okay, well, when we multiply this out, 1 times x minus 5, when we multiply fractions, we multiply numerators, we multiply denominators, we get x minus 5 over x minus 2 times x minus 5. And here we have then 1 times x minus 2 is just x minus 2 over x minus 5 times x minus 2. Now we have the same denominator, so we can add the numerator. And now we just simplify. And x, we don't even really need the parentheses here because we've got a plus, but anyhow, this gives us 2x minus 7. And there's our result. Okay. Okay, let's see. And what we mean by the P of x If P of x is 2x minus 7, Q of x is x minus 2 times x minus 5, then this is a P of x over Q of x. Okay. Now we've got, I don't think I could have washed that, couldn't I? Anyhow. Okay, so we have f of x equals 4 over x minus 2. So we want to find f of 6. Well, if we have f of 6, then x is 6, right? So you got to use 6 for x, 4 for x minus 2. Okay? And then we simplify that. It's 2/3 minus 2, so it would be negative 4/3. But if you just write this out, I'm relatively happy. Best if you simplify it, okay? It wouldn't penalize severely if you didn't simplify it, because we're just testing if you understand function notation. And if you write this out, then you demonstrate here that you understand the function notation for number. And actually, trying to read this around my mask, that wasn't really part of the question. The question was f of 6 minus f of 5. And it was f of negative 5. Okay? So what's that? Well, f of 6 is what we said, is 4 over 6 minus 2. So there's my f of 6. F of negative 5, well now, x has been replaced by negative 5. So we replace all the x's by negative 5, and we get minus 4 over 5 minus 2. Okay? And then, you know, this equals negative 4/3 minus negative 6/5. And you can add the fractions. It'd be a good thing to do. But if you write down this much, I would probably not penalize. I just say, hey, you really should have simplified this. I trust you know how to do that. Okay, then we ask, is it true that f of 6 minus 5 equals f of 6 minus f of 5, because people will always want to try to write this down. Okay? Well, one good way to get out of the habit of writing this down is to show that it's just not true in most cases. Well, f of 6 minus 5 is f of 1. And f of 6 minus f of 5 is negative 4/3 minus, well, we'll just say plus 6/5, just doing the minus of a minus here, right? And what's f of 1? And I'll put a question mark over this equal sign, because we're trying to test if it's equal, right? Well, 4 over 1 minus 2 is 2. Okay? Negative 4/3 plus 6/5. This is a negative number that's a little bigger than 1. This is a positive number that's a little bigger than 1. No way they're going to add up to 2. They're going to be pretty close to 0. Now, you can go ahead and say that this is negative 20 over 15 plus 24 over 15, which equals 4 over 15 Not so, not even close, right? So that should discourage you from assuming there's some kind of a distributive law here, because this notation is not multiplication. Okay, it's a rule for the function. If it was multiplication, that would be okay, and it kind of looks like multiplication. Okay? So I'll say f of 6 minus f of 5, f of 6 minus 5 looks like multiplication, but it ain't. Okay? It's a rule. And we have to understand that. That's a common error people make. Okay. Now, another one about function notation. F of x is negative 3x squared minus 5. And this is really the same question as number 9, but with symbols. So what we want to say is f of p plus q equal to f of p plus f of q. Well, what is f of p plus q? Well, x has been replaced by p plus q, right? So we have to replace x here by p plus q. We get negative 3 times quantity p plus q squared minus 5. Okay? Now, f of p, you're replacing x by p. So you have negative 3 p squared minus 5. And then f of q is going to be negative 3 q squared plus 5. Are these two equal? Well, on the right-hand side, we can simplify. And this is minus 5, not plus 5. This simplifies rather easily to 3p squared, negative 3p squared minus 3q squared minus 10. He's got the negative 5 and the negative 5. Over here, I'll stick with the distributive law. Just so you don't try to write this as p squared plus q squared, right? Because that's another common error. The square of the binomial you get by the distributive law. Now there's special products and stuff like that, but again, so you go to the distributive law until you're really confident about special products. Okay. If you use the distributive law, this tells you have negative 3 times p squared plus 2pq plus q squared plus 5, and over here you have negative 3p squared minus 3q squared minus 10. Expanding this, you get negative 3p squared minus 6pq minus 3q squared plus 5, and that should equal negative 3p squared minus 3q squared minus 10. Well, you can see right away that this is not going to be equal, because in the first place, the only non-variable number you have here is 5, and the only non-variable number you have here is negative 10. It actually should be negative 5. I started doing that sometimes, just writing down the wrong sign. I'd like to blame it on the mask, but I'm not sure that's the only reason. Okay, I'm just being careless. So we have minus 5 here and a minus 10 here. They're not the same, right? So these can't be the same. They're obviously different. Okay? But if you want to really Yeah, another thing, we don't have any PQs over here, right? If you really want to make it clear, you subtract or add 3p squared plus 3q squared both sides. And you get negative 6pq minus 5 equals negative 10. Clearly not so, unless you have just the right PQs, right? And PQ are unspecified. So I'll say it's clearly not slow for arbitrary P and Q. Now you select any numbers you want for P and Q, it's probably not going to make this true. Okay? Now, PQ would have to be what? Negative 5, 6. No, 5, 6. So you'd have to pick two numbers that multiply out to 5, 6. Could be easy. P could be 5, Q could be 1, 6, but it's not true for any other. Well, it's true for a bunch of other numbers, but it's not true if P is 2 and Q is 3. Okay? In order to say that this is a true statement, we're saying that this is an identity. We're saying that this is true for all PQ. Okay? So we've shown that it's not. So, again, you can't distribute this F notation over an addition. Okay. Now, toolkit functions. Remember we did the toolkit functions first thing in the semester. This is something I do want you to know because it's the whole foundation for pre-calculus course. It's the glue that holds the whole course together. So, basic squaring function is y equals x squared. You have a table you can make for this. Remember, well, I said there's a table, and I immediately step one step ahead of what I was saying, do set of coordinate axes. That your table, remember we use x values, negative 2, negative 1, negative 1/2, 0, 1/2, 1, 2. Remember doing that? Okay, you might not have thought about it much since then because we haven't overly emphasized it, but it's a very important thing. It's again, in most of our pre-calculus courses, it's like the first or second thing you see when you come in. And since we want to start a pre-calculus course, by avoiding as much pain as possible, gives us a much better start, gives us more confidence. We want to be sure we understand these functions. So the way I'm advising you to understand these functions is by being able to make the tables and sketch the graphs. And I'm talking about hand sketch the graphs, don't use technology to sketch the graphs. There are appropriate places for technology, but almost nobody uses it appropriately, so I don't even like to use it. Now, I recommend that you review what we did. Because it's just 1 hour or two. review a lot of topics. We don't have time to do that, so there's the function, okay? At least on the domain from -2 to 2. Basic reciprocal function is y equals 1 over x. So we can write down our x values, and we can write down our y values, -1/2, -1, -2. Division by 0 is undefined, so we don't use 0. We cross that line out. And we get a graph. Looks like this: -2 here, 2 here. Subdivide the interval from -2 to 0 in half. Here, that gives us our -1. Subdivide this interval in half, and we've got a reasonably scaled graph, understanding that here's 0, 1/2, 1, 2. Okay. On the y-axis, we do the same thing. So we put 2 here, so 1 would be here, and 1/2 would be here. And then we plot our points. Here, here, and here. And the negatives, I label my -2 there. So we put a point here, point here, and a point here. So this much of the graph looks like this. The graph doesn't cross the y-axis. One over x is undefined. For x equals 0, so the graph doesn't cross the x-axis. Now there's more to it, but for the basic function, as I had you draw, it stops here and it stops here, just between here and here. Okay? We don't worry about what else it does. In pre-calculus, you will worry about what it does, but if you understand this much, then it becomes easy to understand what it does, provided you understand the arithmetic that we use in evaluating the function. Okay? Now, I'm not going to do the rest of the functions because we've done them, and we don't want to spend the whole time repeating something that was done pretty thoroughly at the beginning of the course, okay? But then, just for terminology, basic exponential function is y equals 2 to the x. Basic reciprocal square function is y equals 1 over x squared. And the basic cubic function is y equals x cubed. The graphs turn out, without doing the table and everything, to, kind of stuck there and messed up my curve. Now, kind of like this for the basic exponential function. Basic reciprocal square is kind of like this. Somewhat steeper than the basic reciprocal function for reasons that are obvious if you do the table and understand the arithmetic. And basic cubic function has a graph looks like this. And it really flattens out a lot. It becomes horizontal just for an instant at the origin. If you don't graph it carefully, especially where x equals 1/2 or negative 1/2, and then locate those points very carefully, you won't get that flattening, and your graph will not be completely correct. So I really kind of would want to see the flattening of that. Now this problem, there are 5 of these things. It randomly selects one of them. It says for number 3. You go to the next version, what does it say? It says number 3. I hope it doesn't always say number 3. Let's see. If it does, I'll have to do a little editing. And number 2 on the 3rd. And number 4 on the 4th. So it randomly selects. It just happened to randomly select the same one twice in a row, but that'll happen. Okay? Roll dice, so you can get 5 twice in a row, right? Usually you don't get twice in a row, but it certainly happens. And, okay. That's most of what I've marked here. I've got a list of numbers up here that I also want to look at. Okay, and on version 2, I saw that number 4 was also selected. But it's the same thing as number 1, just a different function, okay? And the question there is what's the Q of X and what's the Q of X? Yes. Can you hold the question? Write it down and bring it up in a little while, because unfortunately I can't pause the video. That's the advantage of this camera here. Okay, they're both sharp. They both give a good image, but I can't pause this one. I'd have to start a new video, and it confuses the posting process, and we kind of want to see this as a whole, okay? So, of course, we'll start a new video after we get some questions. If you got a question you can't hold, just say so, because I'd rather split the video than not answer your question, okay? So be sure that we answer it. Okay, now there are a couple others. Let's see. One, we have 12 and 13, as well as number 1.